This video is going to be applications of quadratic equations. Determine the length of each side, round your answer to the nearest tenth. I have a right triangle and I'm looking for the lengths of the sides. You should automatically think Pythagorean theorem. A squared plus b squared equals c squared. A and b are the two sides that form the right angle. Those are called the legs, and c is the hypotenuse. So I'm going to have 2m squared plus 2m plus 3 squared equals 5m squared. One thing I want to point out, one thing I don't like about this problem is that they use m for the variable. To me, when I see m on a geometric shape, I automatically think m is meters, but it's not. It's just a variable. And I really wish that my math lab would have chosen a different variable to use, but since they didn't, I wanted to use the same variable they did just to point that out. That's not meters, it is just a variable. Okay, so from here, there's a couple of things that I can do. I could write this out. I could use the power rule. I'm going to write this out as 2m times 2m. I'm going to write this as 2m plus 3 times 2m plus 3. The common mistake that students make on these type of problems is not multiplying this out correctly. It's careless mistakes like that that seem to come up and grab you on test. Okay, so from here we're going to combine our like terms and put everything over on the left-hand side and set it equal to 0. Okay, so now I have negative 17m squared plus 12m plus 9 equals 0. I do not like having my leading coefficient negative, so I'm going to divide through by -1. If it doesn't bother you to keep that negative there, then go ahead and keep it if you want to. Okay, now I have my quadratic formula here ready to be simplified. So when I put this in the calculator, I do not want to put that radical sign in the calculator. Just put the stuff that's under the radical sign in the calculator. You're going to get 756. And now I can take this and break this up into two different numbers. Okay, on the left-hand side, here I'm going to get m to be approximately 1.16, and on the right-hand side, I'm going to get m to be approximately, negative 0.46. But remember, I'm talking about the lengths of the sides of a triangle, so I can't have a negative length. This can't be negative. So I only want the 1.16. But I'm not finished because my directions did not say to figure out what m is. My directions were to determine the lengths of those three sides. So now I have to take the 1.16 and put it back in place of the m's. Okay. So let me sketch this out again just real quick here so I don't have to keep scrolling up and down. This is 2m plus 3. And m was 116. So the side that's 5m is going to be 5 times 1.16. And that's going to be about 5.8. I'm going to round to 1 decimal point. And 2m is going to be 2 times 1.16, and that's 2.3. The third side is 2m plus 3. I already have 2m as 2.3, so I just have to add 3 to that, and I get 5.3. One thing I want to point out to you here is that when I found the m, I took it out to 2 decimal places because I don't want to round too early, because if you do, you're going to be off on your final answer. Okay. In a right triangle, the longer leg measures 2 more than the shorter leg, and the hypotenuse measures 4 more than the shorter leg. Determine the length of each side. So I've already drew in my triangle and labeled the sides. And again, I am thinking Pythagorean theorem, a squared plus b squared equals c squared. So x squared plus x plus 2 squared equals x plus 4 squared. I'm going to go to pause this and let y'all try to simplify that out and set that equal to 0. Okay, here I have everything multiplied out. This is set equal to 0. And now I'm ready to solve my quadratic. And what you should see there is that this is going to be able to factor. That should always be your first thing that you check to see if it can be factored before just jumping into the quadratic formula. This is going to factor into x minus 6 times x plus 2. Set each factor equal to 0 and solve. So I have x equals 6 and x equals negative 2. And again, I can't have a negative for an answer. So my x value is 6. Let me scroll back up here and look at my original problem. Okay, this side down here is going to be 6. This side will be 6 plus 2, which will be 8. And this side is 6 plus 4, which is 10. In this example, we're talking about another right triangle. The diagonal of a rectangular room is 26 feet long. One wall measures 14 feet longer than the adjacent wall. Find the dimensions of the room. Okay, there's the sketch of the room. And again, since I've got a right triangle, I'm talking about the Pythagorean theorem. So when I multiply everything out here, remember I'm foiling. I'm going to get x squared plus 28x plus 196. It's going to be equal to 676. I'm going to combine my like terms. Then I'm going to subtract 676 from both sides of the equation so I can set this equal to 0. Now I have my quadratic. I have it set equal to 0. I can either try to factor or use the quadratic formula, but I notice that all of my terms here are divisible by 2, so I'm going to divide this whole equation by 2. So I have now a simple quadratic. My leading coefficient is 1. Again, I can try to factor this or use the quadratic formula, and I'm going to factor. I'm going to set each factor equal to 0 and solve. And because my x represents a length, x cannot be negative, so I know that x is 10. So the dimensions of my room are going to be 10 feet here and 24 feet here. A lot is in the shape of a right triangle. The shorter leg measures 180 meters. The hypotenuse is 60 meters longer than the length of the longer leg. How long is the longer leg? So the first thing that we need to do is to sketch out a picture. It doesn't really matter which side we call A and which side we call B, but it does matter which side is C. C is the hypotenuse, which is the side opposite the right angle. It's always the longest side. So A and B are the two sides that form the right angle. Once I substitute into the Pythagorean theorem, then I can multiply everything out. Okay, so I have a quadratic equation, so I need to try to get everything to one side of the equation. So I'm going to start by subtracting the x squared from both sides. But notice that when I do, the x squareds cancel out on both sides of the equal sign. So I no longer have a quadratic equation. I have a linear equation. So now I need to change my game plan. I no longer need to get everything to one side of the equation to use the quadratic formula. I need to subtract the 3600, then divide by 120. So I get x to be 240. And x is the length of the longer leg, so my answer is 240 meters. A rectangle has length 2 meters less than twice its width. When 5 meters are added to the width, the resulting figure is a square with an area of 144 square meters. Find the dimensions of the original rectangle. Okay. Draw out my original rectangle here, and the first sentence tells me that the length is 2 meters less than twice the width. Now normally it's a good idea to let your variable be what your sentence ends with. So W is the width, so I'm going to put W there. 2 meters less than means I'm subtracting 2 from something. So what am I subtracting it from? I'm subtracting it from twice the width. And I know that I'm going to do something to this. I'm going to end up with a square. So I'm going to come over here, make a square. And my pictures are not going to be to scale, but that's okay. 5 meters are going to be added to the width. So this is now W plus 5. I think that whoever wrote this problem was expecting you to multiply these two sides together and get 144, right? Because the length times width is going to give you that area. And, you know, to either factor or use the quadratic formula to solve it. But there's actually an easier way to do this problem. This is a square, and I know that the area of a square is side squared. And I know that the area is 144. So each side is 12 meters long. This side that's listed as W plus 5 is 12 meters. So W plus 5 equals 12. So the width is 7. Okay. The width is 7. I'll go over here and write that down because it goes with this original picture over here on the left-hand side. And then the length is 2W minus 2, so 2 times 7 minus 2, and that is 12. And these are in meters. Now, I also know that this is 12 meters because this is a square. These two sides are the same. So once I figured out that this side was 12, then I could have figured out W from there. A rectangular piece of sheet metal has a length that is 4 inches less than twice its width, and a square piece, 2 inches on each side, is cut from each corner. The sides are then turned up to form an uncovered box of volume 256 cubic inches. Find the length and width of the original piece of metal. And as always, when you start with a problem, word problem, especially one that's based in geometry, you need to sketch a picture of what's going on. This whole width of the piece of sheet metal, I'm going to call W. And this whole length is 4 inches less than twice the width. So this is 2W minus 4. Each square that I'm going to cut out is 2 by 2. Now, if I look at just this part here that I am highlighting yellow, I know that its length is going to be W minus 2 because I'm taking 2 inches off on each end. So that length is going to be W minus 4. And a similar thing with what I'm going to highlight in blue down here. Remember, this whole bottom line of the rectangle is 2W minus 4, but I'm taking off an additional 4 inches, so this is going to be 2W minus 8. If I fold this piece of sheet metal up along these red dotted lines, I end up with a box. And the length of this box here is going to be the same as what's this side of the metal. This yellow width here comes from the yellow width of this piece of the sheet metal. And the height of the box is going to be 2, because that's the edges that we have turned up. Okay, so what I have over here in my diagram to the right is a box, and I know all 3 sides, and I also know its volume. The formula for the volume of a rectangular prism is on your reference sheet. The volume in this problem is 256. That was given to me in the original problem. The length, width, and height are given to me in the picture toward the right. Normally when I have a problem like this, I would want to start by multiplying out, but because I have a factor of 2 right here, and I know that this number is divisible by 2, I'm going to divide both sides of my equation by 2. And now I'm going to multiply out the right-hand side. So I've got a quadratic equation. I want to get everything to one side of the equation to set it equal to 0. So from here, I could try to factor or try to use the quadratic formula. Actually, because I know that all 3 of these numbers are even, they're all divisible by 2, I'm going to divide the whole equation by 2. Okay, so now I have some smaller numbers to work with. I can see that this can be factored. Then I'm going to set each of my factors equal to 0 and solve. So here I have 2 answers for W, 12 and negative 4. But remember that W is supposed to be the width of my original piece of sheet metal. And a width cannot be a negative number. So I know my width has to be 12. Okay, so once I have the width being 12 inches, I'm not quite done because I'm supposed to find the length and the width of the original piece of sheet metal. And the length is going to be 2W minus 4, or 2 times 12 minus 4. And so that is going to be 20 inches. The area of a square is 100 square centimeters. If the same amount is added to one dimension and subtracted from the other, the resulting rectangle has an area 4 square centimeters less than the area of the square. How much is added and subtracted, and what are the dimensions of the resulting rectangle? So I actually have 2 pictures to sketch out here. My original square and then the rectangle that I have after I make some adjustments to the original dimensions. Okay, I start off with a square whose area is 100 square centimeters. I know the formula for the area of a square is area equals side squared. So I can take the square root of both sides and I get each side to be 10. Now I'm going to take each of these sides. To one side, I'm going to subtract some number, and to the other side, I'm going to add that same number. So I get a rectangle whose dimensions are 10 minus x and 10 plus x. And I know the area is 4 less than the square, so my area is 96. So on my picture toward the right, I have a rectangle, and I know its area. Area is length times width. So I'm going to multiply these binomials on the right-hand side of my equal sign. Now there's several ways that I could go about trying to solve this problem. But because I have an equation with just one term with the variable, I'm going to isolate that variable. So I'm going to subtract 100 from both sides of the equal sign. Then I'm going to divide both sides by -1. So once I divide through by -1, I'm going to take the square root of both sides. So x is positive or -2. And because I'm only looking at a distance here, my number is going to be +2 and my units is centimeters. Be careful, and once you get here, you're not done. I'm also asked to find the dimensions of the resulting rectangle. So substituting 2 back in place of x, I get this side to be 8 centimeters, and this side is going to be 12 centimeters. A swimming pool is 29 feet wide, 47 feet long. The club members want an exposed aggregate border and a strip of uniform width around the pool. They have enough material for 320 square feet. How wide can the strip be? Okay. So your first rule of problem solving is to draw a picture. Okay, so I have my swimming pool that's 29 by 47. I'm going to put a border around it, and I do not know the width of this border, but it's supposed to be a uniform width, so I'm going to call that length x. This is x, and then going horizontally, I have this to be x and this to be x. So this whole width here of the swimming pool and the border is 29 plus 2x, and this whole length of the border plus the length of the swimming pool is 47 plus 2x. Okay, so I've colored my border in yellow just so I can talk about my big picture here. What I want to do is to get an equation that will allow me to find the area of that yellow part, because I know from my original problem that yellow part has to be 320 square feet. That's how much material we have to cover that border. Okay, so my box is down here at the bottom of the screen, shows me my thinking in this problem. If I take the area of the big rectangle, subtract out the area of the pool, that will leave me with the area of the border, which is that yellow part. So I'm looking at my picture and the labels for the lengths and widths and substitute in to this formula. So now I'm going to multiply this out, combine my like terms. So I have a quadratic equation. I'm going to get everything to one side of the equal sign. So from here, I can try to factor, or I can use the quadratic formula. Actually, I know that all three of these numbers are divisible by 4, so I'm going to divide my whole equation by 4. And again, I can factor or use the quadratic formula. This can easily be factored: x plus 40, x minus 2, set each factor equal to 0, and solve. So I get x to be negative 40 or x to be positive 2. But remember that x is standing for the length, and length can only be positive. So my answer is 2 feet. A rug is to fit in a room so that a border of even width is left on all 4 sides. If the room is 12 feet by 15 feet and the area of the rug is 108 square feet, how wide will the border be? And round your answer to the nearest tenth when appropriate. So I'm going to start off by making a sketch. Okay, my room is 12 by 15, and the rug that is going in the room I do not know the dimensions of, but I do know that this border is going to be the same on each side, and we're going to call that X. So looking at this horizontal line here, I know that the length of this rug is going to be 15 minus 2x. And looking at just this yellow part here, I know that that length is going to be 12 minus 2x. So my area of my rug is length times width. The area of the rug is supposed to be 108. Length is 15 minus 2x. The width is 12 minus 2x. So I'm going to multiply out the right-hand side. Over here on the right-hand side, I'm going to rearrange my terms because I want my x squared term first. And then what I'm going to do is to try to get everything to one side of the equation, I'm going to subtract 108 from both sides. Okay, so from here, you can use the quadratic formula, or you can try to factor this. Actually, I'm going to divide everything by 2 because I know that I've got all even numbers here. They're all divisible by 2. Okay, so from here, I'm going to use the quadratic formula. Once I get to this step, I take the square root of 441. I get 21. So I can see that I'm going to have 2 rational answers. One of my answers is going to be 27 plus 21, all divided by 4. And that's going to be 12. My other answer is 27 minus 21 divided by 4, and that is 2. So both of my answers are positive, but I really can only have one answer. So if I go back up to my original problem, I know that if I tried to put 12 back in place of x, that means the width of this rug would be negative, and that can't be. So I know that my answer has to be 2, and this is going to be 2 feet. A toy rocket is launched from the ground level. Its distance in feet from the ground in t seconds is given by the following equation. At what times will the rocket be 550 feet from the ground? Round your answer to the nearest tenth. Okay, so what's going on here is I've got a rocket that's going up and coming back down. And the height at any given time is given by this equation. At what times will the rocket be 550 feet from the ground? Let's say 550 feet is at this height. So it's going to be at 550 feet on the way up, and then again on the way down. So my equation, S of t, kind of like f of x, equals negative 16t squared plus 208 times t. This S of t is your distance, and your distance is 550. So you have a quadratic equation First thing I'm going to do is to put this in standard form. So I will have 16t squared minus 208 times t plus 550 equals 0. And from here, I'm going to put the equation in the quadratic formula. Okay, now I've got that all plugged into my equation. What I'm going to do next is to put the radicand in the calculator. Now, the radicand is the number that's under the radical sign here. Put that into the calculator. Don't put the square root in, just the number that's under your radical sign, and you're going to get 8,064. And that's going to be divided by 32. Now, I have two different answers here. And the reason why I'm getting two different answers is because I have the ball hitting at 550 feet when it's going up, and then is it a ball or a rocket, whatever it is, it's going to be at 550 feet when it goes up, and then again on the way back down. So I'm going to write this expression here into two different answers. So 208 plus the square root of 8,064, and then 208 minus the square root of 8,064, right? And then divided by 32. For this first answer, I'm going to get t to be approximately 9.3 seconds. And over here, t is approximately 3.7 seconds. The function defined by d of t equals 13t squared minus 73t gives the distance in feet that a car going approximately 70 miles per hour will skid in t seconds. Find the time for the car to skid 276 feet and round your answer to the nearest tenth when appropriate. Okay, first of all, the 50 miles per hour is not going to factor into us doing the problem. That's sort of built into our formula, so we don't need to be using that. The d sub t stands for the distance as a function of time, and I know that that distance is going to be 276 feet, so substituting that into my formula, I get this. I'm going to set my equation equal to 0. Then I'm going to use the quadratic formula. So I end up with two answers, one being positive and one being negative, and time being negative does not make sense within this problem. So my answer is 8.2 seconds. A rock falls from a tower that is 93.1 meters high. As it is falling, its height is given by this formula. How many seconds will it take for the rock to hit the ground? So when the rock hits the ground, the height is going to be 0. And we're asked to round our answer to the nearest tenth. So we're going to put 0 in place of h. Since I only have one term with a variable, I can isolate that variable. So I'm going to subtract 93.1 from both sides of my equation. So I get negative 93.1 is equal to negative 4.9 t squared. Then I'm going to divide both sides of my equation by negative 4.9. So that gives me 19. So from here, I take the square root of both sides. And again, normally I would have positive and negative for my answer, but because t is time, it doesn't make sense for time to be negative. So t is going to be the square root of 19, which is approximately 4.4, and that is going to be in seconds.